Hello, good morning students. In the previous class, we studied atomic radius, ionic radius, periodic properties. Today, we'll study one more very important property, that is ionization enthalpy. Ionization enthalpy is the energy. It's the amount of energy required for what? Required to remove an electron, usually last electron, outermost electron, valence electron. Elinda from an isolated gaseous atom in its ground state. Okay, so that amount of energy required to remove an electron is called as ionization enthalpy. For example, say this is a neutral atom present in a gaseous state. This atom is isolated. Meaning of isolated is what? It's a separated, a single atom. Okay, and it's present in a ground state, lower energy state ಅಲ್ಲಿ ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. Suppose from this atom, if you want to remove an electron, one electron, outermost electron, okay, so we need to supply certain amount of energy. The removal of electron from an atom requires certain amount of energy. That energy, that enthalpy is called ionization enthalpy, so that the neutral atom converted into a positive ion, neutral atom converted into positive ion whenever it loses an electron, the energy required is called ionization enthalpy. Ionization energy nu antare. It is also known as ionization potential. All the words are meanings are same. Ionization enthalpy, ionization energy, or we call it as ionization potential. Look here, say X is an atom which is in a gaseous state. It's a separated atom present in a ground state. Okay, suppose if an electron is removed from an X ದಿಂದ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನ ರಿಮೂವ್ ಮಾಡಬೇಕಾದ್ರೆ ಸ್ವಲ್ಪ ಎನರ್ಜಿನ ಸಪ್ಲೈ ಮಾಡಬೇಕು. ಇಟ್ ರಿಕ್ವೈರ್ಸ್ ಎನರ್ಜಿ ಶುಡ್ ಬಿ ಪ್ರೊವೈಡೆಡ್. ದಟ್ ಎನರ್ಜಿ ಇಸ್ ಕಾಲ್ಡ್ ionization energy, such that the X, whenever loses an electron, neutral atom loses an electron, it gets converted into a positive ion, X plus. Clear? Okay, we'll take an example. Say sodium atom from a sodium isolated gaseous neutral atom. If an electron is removed, certain amount of energy should be supplied for that removal of electron. Okay, ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನ ಸೋಡಿಯಂ ಅಟಮ್ ನಿಂದ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಸ್ವಲ್ಪ ಎನರ್ಜಿನ ಸಪ್ಲೈ ಮಾಡಬೇಕು, ಎನರ್ಜಿನ ಪ್ರೊವೈಡ್ ಮಾಡಬೇಕು. ದಟ್ ಅಮೌಂಟ್ ಆಫ್ ಎನರ್ಜಿ ಇಸ್ ಕಾಲ್ಡ್ ionization enthalpy, so that Na converted into a ion, positive ion, that is Na plus, sodium ion. Here IE value, IE andre ionization enthalpy, is equals to 495 kilojoules per mole of energy. That means if one electron is removed from a sodium atom, 495 kilojoules per mole of energy should be supplied to remove that electron. Hence this value is what? Ionization enthalpy. This ionization enthalpy is measured in terms of the unit kilojoules per mole. Clear? What's meant by ionization enthalpy? Okay, fine. Now we'll see the second ionization enthalpy. Before understanding second ionization enthalpy, we'll see what is first ionization enthalpy. Okay, so it's the amount of energy required to remove the last electron, last loosely bound electron. ಅಟಮ್ ದಿಂದ ಲಾಸ್ಟ್ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ನ ರಿಮೂವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಏನು ಎನರ್ಜಿ ಬೇಕಲ್ಲ, ಅದಕ್ಕೆ ಫಸ್ಟ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, ವಾಟ್ ಎವರ್ ದ 3 equations I have explained, they all are examples of a first ionization enthalpy explanation. Okay, then what's the second ionization enthalpy? It's the amount of energy required to remove the second most loosely bound electron. Okay, ಫಸ್ಟ್ ಲಾಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಎನರ್ಜಿ ಬೇಕು, ಅದು ಫಸ್ಟ್ ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ. ಆದರೆ ಇಫ್ ಯು ವಾಂಟ್ ಟು ರಿಮೂವ್ ದ ಸೆಕೆಂಡ್ ಮೋಸ್ಟ್, ಒಂದು ರಿಮೂವ್ ಆದಮೇಲೆ ಮತ್ತೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ನ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಏನು ಎನರ್ಜಿ ಬೇಕಲ್ಲ, ದಟ್ಸ್ ಕಾಲ್ಡ್ ಸೆಕೆಂಡ್ ಅಯನೈಸೇಷನ್ enthalpy. Look at this expression, look at this equation, it's clear to you. Here from a neutral atom X, if an electron is removed by supplying energy IE1, it converted into X plus. From X plus, X plus is formed how? By removing the last one electron. ಈಗ ಮತ್ತೆ from X plus ದಿಂದ if you want to remove one more electron, it gets converted into X2 plus. Okay, so for this conversion, again what is required? Certain amount of energy is required. That's also called ionization enthalpy, but now it's called second ionization enthalpy. Here X ದಿಂದ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಎನರ್ಜಿ ಬೇಕಲ್ಲ, ಅದು ಫಸ್ಟ್ ionization enthalpy. X ಪ್ಲಸ್ ದಿಂದ ಇನ್ನೂ ಒಂದು ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಏನು ಎನರ್ಜಿ ಬೇಕಲ್ಲ, ಅದು ಸೆಕೆಂಡ್ ionization enthalpy. ಕ್ಲಿಯರ್? ಓಕೆ, ಈ ಎರಡು ಇಕ್ವೇಶನ್ ನೋಡಿದರೆ ಗೊತ್ತಾಗ್ಬಿಡ್ತದೆ ವಾಟ್ಸ್ ಫಸ್ಟ್ ionization enthalpy and what is second ionization enthalpy. Okay, now the second ionization enthalpy will be higher than first ionization enthalpy. This IE2, second ionization enthalpy, is always greater, higher than first ionization enthalpy IE1. Yake? Because it is more difficult. Because it's more difficult to remove an electron from a positive ion than from a neutral atom. Okay, so it's a more difficult to remove an electron from this positive ion X plus. Illi remove ಮಾಡೋದು difficult. ಅದಕ್ಕೆ it requires larger amount of energy than the removal of electron from this neutral atom X. X ದಿಂದ electron remove ಮಾಡೋದು ಕಿಂತ X plus ದಿಂದ electron remove ಮಾಡೋದು difficult ಇದೆ. Therefore it requires more energy. Hence IE2 is greater than IE1. Okay, now in the same way, the third ionization enthalpy will be higher than the second and so on. Okay, third ionization enthalpy means what? If the third inner electron is removed, ಮೂರನೇ ಎಲೆಕ್ಟ್ರಾನ್ ರಿಮೂವ್ ಮಾಡಲಿಕ್ಕೆ ಏನು ಎನರ್ಜಿ ಬೇಕಲ್ಲ, ಅದು third ionization enthalpy, which will be greater than second ionization enthalpy. Second is greater than always first ionization enthalpy. Clear? Okay, what is meant by ionization enthalpy? What's meant by first and second ionization enthalpy? Okay, now we'll see variation of ionization enthalpy in the periodic table, how it varies along the period of the periodic table and how it varies down the group of the periodic table. We'll see. Here I have taken an example of a second period. Elements present in the second period are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Their ionization enthalpy values are like this. Here these are first ionization enthalpy value. Okay, so ಏನು ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ ಅಂದ್ರೆ it will be the first ionization enthalpy. Lithium 520 kilojoules per mole, beryllium 899, boron 801, carbon 1086 and so on. Look at this graph. With some exceptional cases, okay, ಈ ಬೆರಿಲಿಯಂ ಮತ್ತೆ ನೈಟ್ರೋಜನ್ ಎರಡು ಎಕ್ಸೆಪ್ಷನಲ್ ಕೇಸ್ ಬಿಟ್ರೆ ionization enthalpy increases. Okay, I'll explain those exceptional case later. Okay, ಹಾಗಾದ್ರೆ ಜನರಲ್ ಟ್ರೆಂಡ್ ಏನು? How ionization enthalpy varies along the period? Ionization enthalpy varies ಅಥವಾ increases along the period. Okay, just recall your memory how atomic radius varies. Atomic radius decreases along the period. This we discussed in the last class. But ionization enthalpy increases along the period. ಯಾಕೆ ನೋಡೋಣ ಈಗ ರೀಸನ್. ಎಸ್, when we move from lithium to fluorine, lithium to beryllium to boron up to fluorine or neon across the second period, the nuclear charge increases. Yes, definitely atomic number increases, nuclear charge increases. This we discussed in the last class. And atomic size decreases from left to right. Just now I said, along the period of the periodic table, atomic radius decreases, atomic size decreases, isn't it? So consequently, the outermost electrons are held more and more tightly. So compared to lithium, fluorine atomic radius is small, size is small. When the size is small, electrons are held more and more tightly in case of fluorine than in case of lithium. Therefore, so from lithium removal of electron is easy, or from fluorine it is easy? Definitely from lithium removal of electron is easier, requires lesser energy. Fluorine, the electron is more strongly held by the nuclear charge. Because the size is small, the removal of electron becomes a bit difficult. Therefore, it require higher energy. ಅದಕ್ಕೆ ನೋಡಿ, lithium 520 kilojoules per mole of energy is enough, whereas fluorine require how much? 1681 kilojoules per mole of energy. Therefore, removal of outermost electron becomes more and more difficult. ಯಾವಾಗ? When you move along the period, the radius decreases, the atomic size decreases, the electrons are being held more and more tightly from the nuclear charge. There is no shielding effect playing a role here. Therefore, the removal of electrons becomes more and more difficult. Hence, ionization enthalpy increases along the period. ಹೌದಾ? So look here. So along the period ಹೋದಾಗೆಲ್ಲ removal of electron becomes what? More and more difficult. Hence it increases. Clear? The answer is what? Atomic radius concept only. Why it increases andre ಎಲ್ಲಿ ಬರ್ತದೆ ಮತ್ತೆ? Atomic radius. Because of a decrease in atomic radius, ionization enthalpy increases. So there are some exceptional cases, are there? No, just now I said you. We'll see those exceptional cases. First one, the first ionization enthalpy of boron is slightly less than that of a beryllium. Okay, look here. The first ionization enthalpy of boron is slightly less than that of a beryllium. So 520, 899 ಗಿಂತ boron ಜಾಸ್ತಿ ಇರಬೇಕಾಗಿತ್ತು. But boron has a less ionization enthalpy than beryllium. Give reason ಅಂತ ಪ್ರಶ್ನೆ ಬರ್ತದೆ. Okay, so question will be like this. Give reason why first ionization enthalpy of boron is slightly less than that of beryllium. What's the reason for this? Okay, we'll see. When we consider the same shell, ಒಂದೇ ಶೆಲ್ ತಗೊಂಡಾಗ S electron is attracted to the nucleus more than the P electron. Okay, in the same shell, S electrons are more strongly attracted by the nucleus than P electron. Okay, this is the basic concept. In beryllium, what happens? The electrons removed during the ionization is an S electron, whereas the electron removed during ionization of boron is a P electron. Okay, we'll compare now. Beryllium, atomic number 4, 4 electrons are there. Electronic configuration is 1s2 and 2s2. Okay, this is the orbital diagram. In 1s orbital, 2 electrons are there. In a 2s orbital, 2 electrons are there. Boron with atomic number 5, electronic configuration is 1s2, 2s2, 2p1. Can you see this cursor here? Okay. Orbital diagram, in 1s orbital 2 electron, 2s orbital 2 electron, and in 2p there is 1 electron. Okay, so in case of beryllium, the 2s electron is removed. Okay, so in case of boron, the last electron yaudu? This is the 2p electron is removed. Okay, in beryllium, the electron removed is what? S electron, whereas in case of boron, it is the removed electron is the last electron is a p electron. Hence, this 2p electron, no, in case of boron, it is more shielded from the nucleus by the inner electron. So these inner electrons are there? No, these inner electron, in case of boron, these inner electron will shield, will screen outer electron from the nuclear charge. ಅಂದ್ರೆ ಈ ಕಡೆ ನ್ಯೂಕ್ಲಿಯಸ್ ಇರ್ತದೆ, ಇದು ಔಟರ್ ಎಲೆಕ್ಟ್ರಾನ್. ಸೊ ನ್ಯೂಕ್ಲಿಯಸ್ ಮತ್ತು ಎಲೆಕ್ಟ್ರಾನ್ ನಡುವೆ ಈ ಇನ್ನರ್ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗ್ತವೆ? ದೇ ಆಕ್ಟ್ ಎಸ್ ಅ ವಾಲ್, ಅಡ್ಡಗೋಡೆ ಆಗಿಬಿಡ್ತವೆ. ಅದಕ್ಕೇನಂತವೆ? ಶೀಲ್ಡೆಡ್, ದೇ ಸ್ಕ್ರೀನ್ಡ್. So this outer electron, 2p electron, is shielded by this inner electron from the nuclear charge. Okay, so therefore it is more shielded in case of boron than in case of beryllium, because in case of beryllium the 2s electron is removed. Therefore it is easier to remove 2p electron from boron. ಈಗ boron ದಿಂದ p electron remove ಮಾಡೋದು easy, beryllium the 2s electron remove ಮಾಡೋದಕ್ಕಿಂತ. Okay, so where it is easy, the removal of 2p electron from a boron is easier compared to the removal of 2s electron. Okay, so ಇಲ್ಲಿ ಈಸಿಯಾಗಿ ರಿಮೂವ್ ಆದರೆ it requires very less energy. ಇಲ್ಲಿ ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಆಗಿ ರಿಮೂವ್ ಆದರೆ it require more energy. Therefore, since the removal of last 2p electron from boron is easier, it has it has less it has less ionization enthalpy than that of a beryllium. Okay, so thus boron has a small first ionization enthalpy than beryllium. This is the first exceptional case. We'll see one more exceptional case here. Okay, so which is that the first ionization enthalpy of oxygen, ಈಗ ಇನ್ನೊಂದು ಯಾವುದು oxygen, is smaller than that of a nitrogen. Okay, actually the oxygen value should have been greater than nitrogen, but it is smaller than nitrogen. Why? The reason is this anomalous property arises because in the nitrogen atom, in case of nitrogen atom, the 2p electron is present in a different atomic orbitals. Look at this, look at this. The electronic configuration of nitrogen is 1s2, 2s2, 2p3. So these three electrons are present in a different orbitals, 2p orbitals. Look at this oxygen electronic configuration 1s2, 2s2, 2p4. Nitrogen 2p3, oxygen 2p4 ಇದೆ. In case of oxygen atom, 2 of the 4 2p electron occupies in the same 2p orbital. There is a increased electron repulsion. Okay, so ಇಲ್ಲಿ in case of 2p the orbitals are singly filled. Okay, it is halfly filled. It is orbitals contain half filled electron. Okay, whereas in case of oxygen, the out of 4 electron, 2 electrons are present in the same orbital. So ಒಂದೇ orbital ದಲ್ಲಿ ಇರೋದ್ರಿಂದ there exists electron repulsion. There is a inter-electronic repulsion is there in case of oxygen. Consequently, it is easier to remove the fourth 2p electron from oxygen than it is to remove one of the 2p electron from nitrogen. So simple words ಅಲ್ಲಿ ಹೇಳಬೇಕಾದ್ರೆ the removal of this oxygen electron is easier than removal of last electron from this nitrogen. Okay, here there is electron repulsion is there. The removal of electron is easier, therefore oxygen has less ionization enthalpy. Whereas in case of nitrogen, there is a half filled orbitals are there, which is extra stable. The removal of electron bit difficult from this stable electronic configuration. Therefore nitrogen require high ionization enthalpy. This is the reason. Okay, so this can also be asked for 1 mark. Now we'll see variation of ionization enthalpy in a group down the group of the periodic table. Okay, so take an example of a first group. Elements present in first group are lithium, sodium, potassium, rubidium and cesium. Their ionization enthalpy, first ionization enthalpy values are 520, 496, 419, 403, 374. Look at this graph. When you move down the group of the periodic table, ionization enthalpy go on decreasing. It go on decreasing. Why? What's the reason? When you move down, definitely the atomic radius increases, atomic size increases down the group. This we discussed in the last class. Okay, ಕೆಳಗಡೆ ಹೋದಂಗೆಲ್ಲ group ಕೆಳಗಡೆ the atomic number increases, the number of shells increases, therefore the distance between nucleus and outermost electron increases, atomic size increases. ಇದು last class concept. As we move down, as we go down a group, the outermost electrons is being increasingly far away from the nucleus. So ಕೆಳಗಡೆ ಹೋದಂಗೆಲ್ಲ size ಜಾಸ್ತಿ ಆಗ್ತದೆ. Then the electron, outermost electron will be away from the nucleus. nucleus ಗಿಂತ ದೂರ ಇರ್ತದೆ. There is an increased shielding of the nuclear charge by the inner electrons, and the removal of outer electron requires less energy down the group. Okay, so as the size increases, the removal of electron is easy because there is a large distance between positively charged nucleus and negatively charged electron. Okay, so inner electrons, what they do? They shield the outer electron from the nuclear charge. Okay, ನ್ಯೂಕ್ಲಿಯಸ್ದು ಲಾಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಮೇಲೆ ಹಿಡಿತ ಕಡಿಮೆ ಇರ್ತದೆ. ಯಾವಾಗ ಅದರದ್ದು ಎಫೆಕ್ಟ್ ಹಿಡಿತ ಕಡಿಮೆ ಇರ್ತದೆ, ಎಲೆಕ್ಟ್ರಾನ್ನ ಈಸಿಯಾಗಿ ರಿಮೂವ್ ಮಾಡ್ಬೋದು. ಈಸಿಯಾಗಿ ರಿಮೂವ್ ಮಾಡ್ಬೋದು ಅಂದರೆ ಕೆಳಗಡೆ ಹೋದಂಗೆಲ್ಲ less and less energy is sufficient. Therefore, when you move down the group of the periodic table, ionization enthalpy decreases. So the removal of electron becomes easier down the group. Okay, so simple answer atomic radius concept. When you move down, atomic radius increases, the outermost electron is more shielded by the inner electron. Okay, so ಯಾವಾಗ ನ್ಯೂಕ್ಲಿಯಸ್ ಮತ್ತೆ ಔಟರ್ ಎಲೆಕ್ಟ್ರಾನ್ ಡಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆಯಿತು, ರಿಮೂವಲ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ ವಿಲ್ ಬಿ ವೆರಿ ಈಸಿಯರ್. Okay, so I'll show this effect. One second. Okay, let me show you how it will be easier. Say this is nucleus of lithium 1s2 2s1. Okay, 1s2 2s1. Say this is say sodium. Its electronic configuration 1s2 2s2 2p6 3s1. So this is lithium atom and this one is a sodium atom ಅನ್ಕೊಡ್ರಿ. Okay, so lithium ಕೆಳಗಡೆ sodium ಇರ್ತದೆ. So the atomic radius of lithium is smaller compared to sodium. Okay, so ಇಲ್ಲಿ ಒಂದು electron ಇದೆ. So removal of this electron is easy or the removal of this electron is easy. ಯಾವ electron easy remove ಮಾಡ್ಬೋದು? So here the distance is more. The attractive force ಅಥವಾ ಪಾಸಿಟಿವ್ ನ್ಯೂಕ್ಲಿಯರ್ ಚಾರ್ಜ್ ಆನ್ ದಿಸ್ ಔಟರ್ಮೋಸ್ಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಈಸ್ ಲೆಸ್. ಸೊ ಹಿಯರ್ ಡಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಆದಂಗೆ ಈ ನ್ಯೂಕ್ಲಿಯಸ್ದು ಈ ಎಲೆಕ್ಟ್ರಾನ್ ಮೇಲೆ ಹಿಡಿತ ಕಡಿಮೆ ಆಗ್ತದೆ. ಬಿಕಾಸ್ ಆಫ್ ದೈಸ್ ಇನ್ನರ್ ಎಲೆಕ್ಟ್ರಾನ್ ದೇ ಶೀಲ್ಡ್ ಇನ್ನರ್ ಎಲೆಕ್ಟ್ರಾನ್, ದೇ ಆಕ್ಟ್ ಎಸ್ ಅ ವಾಲ್ ಬಿಟ್ವೀನ್ ದಿಸ್ ಔಟರ್ ಎಲೆಕ್ಟ್ರಾನ್ ಅಂಡ್ nucleus. Therefore, the removal of this electron is easy. As the distance increases, removal of electron is easy. Therefore, so this sodium has less ionization enthalpy than lithium. Okay, so in the same way sodium ಇಂದ potassium ಹೋದ್ರೆ ಇನ್ನೂ less, potassium to cesium ಇನ್ನೂ less ಆಗ್ತಾ ಹೋಗ್ತದೆ. Is that clear? Okay, so therefore when you move down, ionization enthalpy decreases. Clear? Okay, so this is about today's concept. ಏನೇನು ಸ್ಟಡಿ ಮಾಡಿದ್ವಿ? What is ionization enthalpy, first ionization enthalpy and second ionization enthalpy, how it varies along the period of the periodic table and how it varies down the group of the periodic table. Okay, so I hope this concept is clear to you. If you understand my video, please share this video and subscribe to my YouTube channel. Thank you very much.